In this video, we're going to work through the Edexcel June 2022 A-level Maths Pure Paper 1. So let's begin with question 1. The point -2, -5 lies on the curve with equation y equals f of x. Find the point to which P is mapped when the curve with equation y equals f of x is transformed to the curve with equation, and there's a few things we need to consider. So we're just going to need to think what each of these transformations actually does. We don't know what the curve looks like, but it doesn't matter. So what does this transformation do? Well, f of x plus 2 adds 2 to the y coordinate. So what's that going to do to P? It's going to leave the x coordinate alone, and it's going to add 2 to the y coordinate, taking -5 up to -3. How about question B? Well, the modulus of f of x basically makes all of the y values positive if they're not already positive. So it's going to leave the x value alone, but that -5 y value will become +5. Okay, finally we've got a bit more going on in part C. So there's a few things to do. So it's best to work kind of from the inside out here. So what I'd do is I'd probably keep track of this one transformation at a time. So I'd say, what would f of x minus 2 be doing? Well, that is a translation of 2 units in the x direction. I'm not going to write equals there, but I'll just keep track of what the transformation is. So f of x minus 2 will add 2 to the x coordinate. So that means our -2 is going to become 0, and the y coordinate will stay the same. Now, what happens if we then chuck the 3 on the outside? Well, that's a stretch of scale factor 3 in the y direction, so that's going to leave the x coordinate alone, and it's going to multiply the y coordinate by 3, so -15. And finally, the full transformation, the difference between the one I just got to and adding 2, well, that adds 2 to the y coordinate. So it'll leave the x coordinate alone, and it'll add 2 to the -15, making it -13. And so that's my final answer there. On to question 2. So here is a polynomial. F of x is x minus 4 times x squared minus 3x plus k minus 42, where k is a constant. So given that x plus 2 is a factor of f of x, find the value of k. So by the factor theorem, we know that if x plus 2 is a factor of f of x, then f of -2 will equal 0. So I'll just need to work out what f of -2 is. So that just involves putting -2 into this formula. So that's -2 minus 4 multiplied by -2 squared, which is 4. -3 times -2 is +6, and then there's a plus k here, minus 42. And that should equal 0. So what have we got? We've got -6 multiplied by 10 plus k. And if I add, I'm not going to do that here, equals 0. Now I'll add 42 to both sides. So -6 times 10 plus k equals 42. Divide both sides by -6, and I get 10 plus k equals -7. Subtract 10 from both sides, and we get -17. Okay, question 3. A circle has equation x squared plus y squared minus 10x plus 16 equals 80. Find the coordinates of the center of the circle, and then the radius. So to do this, we need to have it in completed square form. So we need to complete the square for the x's and the y's. I'll basically be answering 1 and 2 in one go here. So for the x's, it's going to be x minus 5 squared. That gets us the x squared and the minus 10x. Then we subtract 5 squared. For the y's, we need to complete the squares on those, and that's going to be y plus 8 squared. Gets us the y squared plus 16y minus the 8 squared. and that equals 80. Gather the squared terms over here. Get everything else over onto the other side. So 80 plus 64 plus 25, and that's 169. And so the center of the circle is 5, negative 8. We get that by looking at this term in the negative and this term in the negative. And the radius of the circle, well, it's r squared over here, and the square root of 169 is 13. Part B, given that P is the point on the circle that is furthest away from the origin, find the exact length of OP. This one probably looks harder than it is. A sketch is useful to get your head around this. We have a circle, and I'm not going to draw this particularly carefully, but we've got a circle with a centre of 5, negative 8. So that's sort of here, let's say. And it's got a radius of 13. So something like that. It's a terrible circle, you get the idea. Now the point furthest away from the origin is the point I'd get if I went from the origin through the centre and all the way through to the other side. That's the point that's furthest away from the origin. So what is that? Well, it's just this distance between the origin and the centre plus the radius. I know the radius is 13, so I just need to work out the distance between the centre and the origin. So the distance between the centre and the origin is simply the square root of 5 squared plus 8 squared, and that's just Pythagoras' theorem, knowing that we've got an x-coordinate of 5 and a y-coordinate of negative 8, so that length is 8 down there. So key all of that into the calculator, and we get root 89 here, which means the maximum distance between O and P, this is the point P over here, root 89, is 13 plus root 89. I just wanted to tell you really quickly about my website, where I have a complete online course covering the full A-level syllabus made up of hundreds of videos, quizzes and worksheets. If you're finding this useful, please check it out using the link in the description, and the first 100 people to use the promo code can get 30% off. Right, back to the paper. Okay, question 4. Express the limit as delta x tends to 0 of... Okay, what on earth is this? Well, this is an integral expressed in its sort of first principles definition. So as an integral, all that's doing is taking the integral between 2.1 and 6.3 of 2 over x dx. Okay, and that's just the definition of what that means. The integral is defined to be the sum of 2x times little changes in x, and it's the sum as those little changes tend towards 0. So that's our 1 marker there. Hence show that this is ln of k, and we need to work out what that is. Okay, so that integral there, well, the integral of 2 over x is 2 ln x, and then our limits are 6.3 and 2.1. So now we're just subbing these values in. So it's 2 ln 6.3 minus 2 ln 2.1. Now we definitely don't want to key that into the calculator. It will give us some decimal. It will be hard to understand. We want to have this in the form of ln something. So I think the easiest way to do that is actually just to notice that 6.3 is 3 times 2.1. If I factorise out the 2, I've got 2 times ln 6.3 minus ln 2.1. I can then use the log law, which says that ln of 6.3 minus ln of 2.1 is the same as ln of 6.3 divided by 2.1, which is 3. Finally, I can use the log law, the power law, which says this is the same as ln of 3 squared, which is 9. So there we go, and k was 9. Question 5. The height h meters of a tree t years after being planted is modelled by this equation h squared equals at plus b, where a and b are constants. Given that the height of the tree was 2.6 meters, exactly 2 years after being planted, and the height of the tree was 5.1 meters, exactly 10 years after being planted, find a complete equation for the model giving the values of a and b to 3 significant figures. Okay. So what we'll need to do here is basically sub the values we have into the equation and use that to find a and b. So when I sub the information here in, I get h, which is 2.6 squared, equals a times t. T is 2 here, so that's 2a plus b. And then 5.1 squared is going to be 10a plus b. So what I have here is simultaneous equations. Now, I guess I'll just work out or write down what 2.6 squared and 5.1 squared are. But actually, I'm going to use my calculator to solve this. So my first equation is 2a plus b equals 6.76. And my next equation is 10a plus b equals 5.1 squared, which is 26.01. Okay, let me show you how to solve that using the calculator. So on your calculator, at least if you have this model, you have an equation solver, and it's down here, equation / function, and we're solving simultaneous equations, so option 1. How many unknowns? 2 unknowns. Now I can just key it in. Now they're using x's and y's, but we have a's and b's. That doesn't matter. We'll just bear that in mind. So it's 2x / 2a plus 1y, or b, is 6.76. And the next one was 10a plus 1b equals 26.01. Our answer is that our x value, or our a value, is, we want 3 significant figures. So 2.41. So A is 2.41, and B, we just press equals again, is this, and that's 1.95. Now, obviously it wouldn't have been too tricky to solve this by just subtraction, but I just like that feature of the calculator and I wanted to show it to you. So, a complete equation for the model is that h squared is 2.41t plus b, which is 1.95. Now we're done. Given that the height of tree was 7 meters, exactly 20 years after being planted, evaluate the model. Well, to evaluate the model, let's see what the model would have predicted after 20 years. It would have predicted that h squared was 2.41 times 20 plus 1.95. So let's just evaluate that. 2.41 times 20 plus 1.95 is 50.15. So h squared is 50.15. And so the model predicts that h will be the square root of that, which is 7.08. Now, in fact, the height was 7 meters, which is very close. So I'd say 7.08 is very close to 7 meters. Therefore, the model, I just need to evaluate it. So I'd say, therefore, the model seems reliable, or something to the effect of that. Reliable or good. Basically, it seems to be doing a good job here. Question 6. Figure 1 shows a sketch of curve C with equation y equals f of x, where f of x is a cubic expression in x. The curve passes through the origin, has a maximum turning point at 2.8 and a minimum turning point at 6, 0. Write down the set of values of x for which f dash of x is negative. So that is when it is a decreasing function. So I can see that it's decreasing between 2 and 6. So that one's nice and straightforward. and it's only 1 mark, so I'm just going to state this. It's when x is between 2 and 6. Okay, the line with equation y equals k, so that's just a horizontal line, where k is a constant, intersects C at only 1 point. Find the set of values of k, giving your answer in set notation. So what we need to know is, if I was to draw a horizontal line across this, where could I do it such that it would only intersect the line once? Well, if I did it through here, it would intersect it multiple times. It would need to be above this maximum turning point or below this minimum turning point. So it's going to be when k is greater than 8 or less than 0. If it's greater than 8, then it's going to be going up here and only intersecting once over here. And if it's less than 0, it intersects once somewhere over here. Now it wants it in set notation. So to do that, we say it's the set of k values such that k is greater than 8. That will sort of skip all of the stationary points above, or the set of k's such that k is less than 0. And that's our set notation value for that. Find an equation of C. You may leave your answer in factorised form. All right, so looking at this, what do we know? We know it's got a root at unrepeated, a single root at the origin and a repeated root at 6. So that means it's a positive cubic. That means it's going to look something like, I'm going to leave a space here, you'll see why, something like x minus 6 squared times x. The x minus 6 squared guarantees that you have the repeated root at x equals 6, and the x guarantees you have a standard root here. However, there could be any multiple in front of this, so I'll just put an a here. Now, that a being bigger would basically stretch the graph out more, and if that a was smaller, it would stretch it, squash it in. We need to guarantee that it goes through the point 2, 8. So I can just sub in x equals 2 and y equals 8 to work out what a is. So when y is 8, x is 2, so we've got a times 2 minus 6, which is negative. I'll just write it in, 2 minus 6 squared, and then times 2. So what we have is 8 equals a times, and it's negative 4 squared, which is 16, times 2, which is 32. So dividing both sides by 32, I get a equals a quarter. And that means that the equation of my line is y equals 1 quarter x minus 6 squared times x. Obviously the order doesn't matter, you could have written a quarter x minus 6 squared, but that's your equation there. Okay, question 7. Given that p and q are integers such that pq is even, use algebra to prove by contradiction that at least one of p or q is even. So the first thing to do in a proof by contradiction is to assume it's false. So what do we need to assume? We need to assume that PQ is even, because that's just given. We need to assume that the opposite of this is true, so not at least one of PQ is even, that is, they're both odd. So what I'm going to say is, suppose PQ is even, but P and Q are odd. And I'm going to see if I can derive a contradiction. So I've assumed that the premise is true, but the conclusion is false. So since P and Q are odd, I can say that P is some arbitrary odd number, which would be 2n plus 1. That's the way we write an arbitrary odd number. And Q is also odd, so Q is a different arbitrary odd number, or potentially different odd number, to m plus 1. And I'll just say that n and m are both integers. Okay, that's just being really kind of precise about that. Okay, well, let's investigate what PQ is. PQ is therefore 2n plus 1 times 2m plus 1. If we expand this, we get 4nm plus 2n plus 2m plus 1. And the problem here is that is odd. How can I prove it's odd? By saying it's 2 times something. In fact, it's 2 times 2nm plus n plus m plus 1. And that means that PQ is odd. Why is that a problem? Because I suppose that PQ is even. So I've contradicted my assumption. So I can say contradiction since PQ is even. And how do I conclude? I can say, therefore, at least one of P and Q is even. Because when I assumed they were both odd, I hit a contradiction. Okay, what's part 2? Given that x and y are integers such that x is negative and x plus y squared is less than 9x squared plus y squared, show that y is greater than 4x. I'm just going to write those things down here. Okay, now what are we aiming for? We're aiming to show that y is greater than 4x. So let's work with this. If I expand this side, I get x squared plus 2xy plus y squared, and that's less than 9x squared plus y squared. Subtracting y squared from both sides and x squared from both sides, I get 2xy is less than 8x squared. Now, I can divide by 2, that's no problem. I just get xy is less than 4x squared. Now, when I divide through by x, when x is negative, the effect of dividing through by a negative number flips over the inequality. So, y is greater than 4x, and I'll just put since x is negative. That's why it swapped that over. And so that's how we prove that given that initial condition, y must be greater than 4x, which is what we needed to show. Question 8. A car stops at 2 sets of traffic lights. Figure 2 shows a graph of the speed of the car, v, as it travels between the 2 sets of lights. The car takes t seconds to travel between the 2 sets of lights. The speed of the car is modelled by this equation here. V equals 10 minus 0.4t ln t plus 1. So I presume that's got this shape, where t is the time after the car leaves the first set of traffic lights. Well, that's where little t is that. According to the model, find the value of t. So the value of t will be where this equation first equals 0. We know that it equals 0 at the origin, but when does it next equal 0? So let's just solve that down here. So setting 10 minus 0.4t times ln t plus 1 equal to 0. Well, there are 2 solutions to that. Either 10 minus 0.4t equals 0, or ln of t plus 1 equals 0. Now, the ln t plus 1 equals 0, that has just one solution. That's when t equals 0. That's the origin solution. The reason for that is that would be when t plus 1 equals e to the 0, which is 1, and that would give that. So that's not our capital T. Our capital T must be where this one equals 0, where 10 minus 0.4t equals 0. So that's when 10 equals 0.4t. And so t is 10 divided by 0.4, which is 25. So that's the value of capital T, so I should probably just write that down. capital T is 25. Okay, show that the maximum speed of the car occurs when this is true. So the maximum will occur when the derivative is 0. So that we're hoping to show that setting the derivative equal to 0 will give this. So again, let's start with the equation that v is 10 minus 0.4 t times ln of t plus 1. So, and this is part B, is it? Or part 2? It's part B. So I'm going to differentiate this and set it equal to 0. So that's going to be dv by dt, and I'm going to need to use the product rule for this. Just to keep track of the product rule, it can be useful to say explicitly that u is 10 minus 0.4 t. Okay, careful now, because you've got u and v in the product rule, and v actually means something in this question, so you might want to use a different letter, but really the product rule is just for your own working. So as long as you know that this v down here is not the v in the question, it's okay. So u dashed is minus 0.4, and v dashed is 1 over t plus 1. So chuck that all in here. It's u v dash, so that is 10 minus 0.4 t over t plus 1 plus v u dash, so that's, well, it's actually minus 0.4 ln t plus 1. I probably should have given myself more room. I'll just box that off so it's clear it's not part of that. So I need to show that that is equal to all of this, and you can see they've got t on its own here, and I can also see a 26. So let's think about how we're going to get there. So first I'm going to set that equal to 0. Now, this is relatively tricky at this stage to rearrange, but let's try to just neaten things up as best I can. I'll start by just getting that 0.4 ln t plus 1 over to the other side. Now, looking at where I'm heading, I can see that we've got a 1 plus ln t plus 1. So why don't I try to create that for myself if I can. Maybe a useful thing to do right now is just divide both sides by 0.4, so I've got ln t plus 1 on its own. When I divide this side by that, I'm going to get 25 minus t over t plus 1. And over here, I just get ln t plus 1. Now, from here, what I would suggest is this. Now, this can look a little bit abrupt when you do it, but when I'm looking here, I'm saying I need a 1 plus ln t plus 1, and I can't quite see how I'm going to get the plus 1. So I'm just going to add 1 plus ln t plus 1. Okay, so I have what I want over here, or at least part of what I want. I need to add 1 on this side as well. Here's a sneaky way to do that. Well, it's not that sneaky, really. It's just algebra, isn't it? 25 minus t over t plus 1. Okay, when I add 1 to this, I can just add t plus 1 over t plus 1, so that I've got a common denominator here. Now, this turns out to be a great move, because when you add these numerators, your t here cancels with the t here, your 25 adds to the 1 here, and you now have 26 over t plus 1. And we wanted 26 in our answer, so that's useful. Okay, looking again up here, it should be 26 divided by 1 plus ln t plus 1. So we can get that pretty easily by multiplying both sides by t plus 1 and dividing both sides by 1 plus ln t plus 1. Essentially swap these two bits around. We get 26 over 1 plus ln t plus 1, and that equals t plus 1, we're basically there now. By subtracting 1 from both sides, I get t equals 26 over 1 plus ln t plus 1 minus 1. So there, it's done. That's a pretty tricky one of these rearrangements, but by just sort of forcing the things that we needed to see into shape, it made it a little bit easier. Okay, with t1 equals 7, we're going to use this iteration formula to find the value of t3 to 3 decimal places, and then we're going to find, by repeated iteration, the time it takes for the car to reach maximum speed. All right, so our iteration formula is this, but basically this just means your next value of t is going to be, and you're going to be subbing values into here. So there's our iteration formula. It's said to take t1 as 7, and we need to find t3. So we're just going to have to use this twice. So t1 is 7. Okay, how to get all your method marks here? Do show that you're subbing 7 into this formula. Show the subbing in once, and you don't need to do it the second time. You're going to get all the method marks for that. So 26 over 1 plus ln of 7 plus 1 minus 1 equals, and then this is how I set this up on the calculator. So I would just do 7 equals, it's in my calculator now stored, and I'll do 26 over 1 plus ln of my answer plus 1, and then all of that minus 1. So T2 is that 7.44. Now for T3, I don't need to key anything in again. I just hit equals again. So 2.30, or 7.30 rather. So that's the first part done. I've found T3 to 3 decimal places. Now find by repeated iteration the time taken for the car to reach maximum speed. That's just hammering on the equals button until it stops moving. So if I just hammer on this, equals, 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 and I do this until it stops moving, well, that's the answer. So 7.3328. Now I'll just glance back at the question to see if it asks for any particular accuracy. The time taken for the car to reach maximum speed, no, so I'm just going to give it to plenty of decimal places. So there we go. Okay, question 9. Figure 3 shows a sketch of a parallelogram PQRS. Given that PQ is 2i plus 3j minus 4k and QR is 5i minus 2k, show that parallelogram PQRS is a rhombus. So the definition of a rhombus is a parallelogram whose sides are all the same length. So what do we know? We know that PQ, that's this bit here, is 2i plus 3j minus 4k, and we know that QR is 5i minus 2k. So to show it's a rhombus, I just need to show that these two are the same length. If those two are the same length, then so are these two, because it's a parallelogram, so PQ is the same as SR, and so on. So what is the modulus of PQ? Modulus of PQ, let's just square it to keep it simple. The modulus of PQ squared is 2 squared plus 3 squared plus negative 4 squared, which is the same as 4 squared. So that is 4 plus 9 plus 16, that's 29. And what is the modulus of QR? Squared, well, it's 5 squared plus 2 squared, which is also 29. So what I've shown is that the modulus of PQ is equal to the modulus of QR. So they're the same length. And therefore, PQRS is a rhombus. Okay, so for part B, find the exact area of the rhombus. Well, you can split a rhombus into two triangles like this. Now we know the length of PQ, we know the length of QR. There are a few ways of doing this. A way that would work, but which would be very slow, would be to work out the length of PR, use the cosine rule to find the angle in here, then use half AB sine C to find the area of this triangle and then double it. We actually use a nice property of a rhombus, which is if we find this length and we find this length, well, we can actually just multiply those two lengths together. Now, the reason for that is if you take a rhombus, let me just show you this all down here. If you take a rhombus, I'll kind of have it neatly arranged on its side, where all of these are the same length, which I haven't quite achieved, but you get the idea. And you imagine snipping it up into four triangles. Imagine taking this triangle here and moving it up here like that. So I've got rid of this bit here, and then take this one and move it up like this. And so we get rid of this bit here. What we've actually just got here is is a rectangle with a base, which is the length across here, and a height, which is, well, it's half of the original height. So it's going to be this base length here, which is just PR in this case. So that's PR multiplied by a height, which is half of the distance across here. So it's half of QS. So we need to work out what PR and QS actually are. So PR, well, we can just think about this in terms of journeys. PR is PQ plus QR. So that's 2i plus 3j minus 4k plus QR, which was 5i minus 2k. In total, that's 7i plus 3j minus 6k. Now we also need QS. So QS, how do we get from Q to S? Well, it's going to be minus PQ and then plus PS. PS is the same as QR. So it's going to be minus this bit. So that's minus 2i minus 3j plus 4k and then plus 5i minus 2k. So to get from Q to S, that was Q to P, which was minus PQ, and then plus PS, which was the same as QR. Simplify this, and we get minus 3i minus 3j plus 2k. So the modulus of PR is root 7 squared plus 3 squared plus 6 squared. All of that inside the bracket, 49 plus 9 plus 36. So that's root 94. And the modulus of QS is the square root of 3 squared plus 3 squared plus 2 squared. So that's 9 plus 9 plus 4, that's root 22. So what that means is that the area is going to be half of root 94 times root 22. How did they ask for it? They said find the exact area. So I'm going to be working out the square root of 94 times 22. Dividing that by 2, we can actually just key the whole lot into the calculator and we get the square root of 517. So that's the exact area of that rhombus. Okay, question 10. A scientist is studying the number of bees and the number of wasps on an island. The number of bees, measured in thousands, NB, is modelled by that equation, which is an exponential equation. T is the number of years from the start of the study according to the model. Find the number of Bs at the start of the study. Well, that's very easy. We just set T equals 0. So when T equals 0, NB, so the number of Bs, is 45 plus 220 times e to the 0, which is 1, and so this is just 265. Show that exactly 10 years after the start of the study, the number of Bs was increasing at a rate approximately 18,000 per year. I now notice that this is measured in thousands, so it's 265,000. There we go. So question B. Okay, so this is a question about the rate of increase. The rate of increase is the derivative. So I need to differentiate this model. So I need to find dn by dt. So differentiate 45, you get 0. If you differentiate 220 e to the 0.05t, well, you need to multiply the 220 by 0.05, and for that you get 11. So it's 11 e to the 0.05t. And we need to work out what that is when t equals 10. So when t equals 10, dn by dt equals, well, it's 11 times e to the 0.05 times 10, which is 0.5. So 11 times e to the 0.5 is 18.14, and it's measured in thousands, so it's approximately, so therefore approximately 18,000 per year is the rate of increase. Okay, the number of wasps measured in thousands, NW, is modelled by this equation. So another exponential equation, but exponential decrease, where t is the number of years from the start of the study. When t is capital T, according to the models, there are an equal number of bees and wasps, and we need to find this value. So that's going to involve just setting these two equations equal to each other. So that's going to be the B equation. So that's 45 plus 220 e to the 0.05t, and that should be equal to our WASP equation, which is 10 plus 800 e to the minus 0.05t. Okay, for this we can neaten things up a little bit by, for instance, subtracting 10 from both sides, but we've got a slight issue here, which is you're going to have an e to the power of 0.05, you're going to have a constant, and you're going to have a minus 0.05t. This is a good time to use a substitution. Now the substitution that's going to be best is just to set this thing equal to u. You're actually going to end up with a quadratic when you do that. Let me show you. So let u, or x, let's just use x, we haven't used x in this equation, x equal e to the 0.05t. Here's what we get. Subtract 10 from both sides and you get 35 here. This side is fairly straightforward then, it's just 220x. Over on this side, well, the 10's gone. Now what's this? E to the minus 0.05t is just 1 divided by e to the 0.05t, so that's 1 over x. So what you have here is 800 over x. Now multiply through by x and you get your quadratic. 35x plus 220x squared equals 800. Get everything onto one side, 220x squared plus 35x minus 800 equals 0. Do not spend any time trying to make this beautiful or easier to interpret. We're just going to get our answers from the calculator. So go into here, go to your equation solver, polynomial, degree 2, and it's 220 x squared, 35x minus 800. And the solutions I get are 1.829. And there's going to be another, what is it? Minus 1.99. Okay, now bear in mind what x was. X was actually e to the 0.05t. E to the 0.05t could be 1.829, but e to the 0.05t could not be minus 1.99. So that does not get you a solution. E to the 0.05t is not negative. So we can just solve this. 0.05t is ln of 1.829, and therefore t is just ln 1.829 over 0.05, and we can work that out on the calculator. Nice thing to do here, by the way, once you get your answer again, this one here, just to keep full accuracy, obviously you can write it down. I could write down loads of decimal places. A nice little trick is just say store that. So store that as A, for example, and that's now stored as A. Go to menu back here and look, there is that number in full unrounded glory. So what do we have? We have ln of A divided by 0.05, and there it is. And that's our capital T. It's 12.08. So capital T is 12.08. Let's just check how they wanted us to round this to 2 decimal places, and so we've got it. 12.08 years is when the populations are the same. Question 11. Figure 4 shows a sketch of a curve C1 with equation y equals 2x cubed plus 10, just for positive values of x, and curve C2 has the equation 42x minus 15x squared minus 7, also for positive values of x. Verify that the curves intersect when x equals a half. Verify just means sub in x equals a half into both of these equations, so that should be very nice and easy. So you can say 2 times a half cubed plus 10. See what that is, so I just type that into my calculator. And it's 10.25. And then with the other curve, 42 times a half minus 15 times a half squared minus 7. Now I'm really hoping this is going to be the same. If it's not, we've got a problem. And lo and behold, it is. Part B then, the curves intersect again at the point P. Using algebra and showing all stages of working, find the exact x coordinate of P. All right, so it's basically setting these equations equal to each other in the knowledge that one of the solutions is x equals half, and also with the knowledge that we only want positive solutions because both of these are defined only for positive values of x. So, since this is 5 marks, you're not really going to get any credit if you were to just stuff this cubic into your calculator and solve it. We really do need to show full working here. So you try to be guided by the marks available. So add 15 to both sides, 15x squared to both sides, subtract 42x from both sides, add 7 to both sides, and here's what we're trying to solve. So we already know that x minus a half is a solution. So that means that 2x minus 1 is a factor. Okay, I'm going to use polynomial division here, and I'm going to use grid method. I know some of you might use long division, and that's fine. Personally, I quite like grid method for this. I think it's easier, basically. So how do we do this? Looking at what I'm aiming for, I need a 2x cubed here. So since that's 2x cubed, this had to be x squared, which means this is minus x squared. In total, I wanted 15x squared, so I needed 16x squared here. What do I multiply 2x by to get that? It's 8x. 8x times negative 1 is minus 8x. I wanted minus 42x in total. That means I needed an extra minus 34x here, which means this had to be a negative 17. That means that this is plus 17, and the fact that plus 17 matches this is good. It had to be since 2x minus 1 is a factor. So what that means is the cubic expression factorizes as 2x minus 1 times x squared plus 8x minus 17 equals 0. I'm not interested in that one, since that's the one that the x equals a half solution that I already have. I'm interested in this one here. So how do they want the answer? They want using algebra and showing all stages of working. Okay, so I just need to solve this now. And since they said showing all stages of working, I'll just resist the urge to key this all into my calculator immediately. Using the quadratic formula, it's negative b plus or minus the square root of b squared, which is 64, minus 4 times 1 times negative 17, so that's plus 68, all over 2a, so that's all over 2. Neaten this up, I think I can use my calculator to help me do this. The square root of 64 plus 68 is 2 root 33. So minus 8 plus or minus 2 root 33 all over 2. I can divide everything on the top by 2, so minus 4 plus or minus root 33. Now, that's two different values, but minus 4 minus root 33 is negative, but x is always positive. Therefore, since x is always positive, x must equal minus 4 plus root 33. And let's just check that's exactly what they want. Find the exact x coordinate of P. And we're done. It's minus 4 plus root 33. Question 12. Solutions relying on calculator technology are not acceptable. Noted. Show that the integral from 1 to e squared of x cubed ln x dx is a e to the 8 plus b, where a and b are rational constants. We need to use integration by parts for this. Remember that for integration by parts, you need to identify one part of your integral to be u and one to be v dash. When one of those bits is ln, that is your u. So my u is ln x, and my v dash is x cubed. So I'll just find v and u dash and then sub these into the integration by parts formula. U dash is 1 over x. Now if v dash is x cubed, v is the integral of that, which is a quarter x to the 4. So the integral is going to be uv, so that's a quarter x to the 4 ln x minus the integral between 1 and e squared of v u dash, which is a quarter x cubed. And that's why we set our u to be the ln x, because its derivative simplifies nicely when you multiply it by another polynomial. So that's a quarter x cubed ln x minus this integral. What is the integral of that? Well, it's going to be 1 over 16 x to the 4. And there's the integral, and I'm just going to evaluate this between 1 and e squared. Right, subbing in e squared, I get a quarter e squared to the 4, which is e to the 8, times ln of e squared. Well, ln of e squared is actually just 2, but I can just leave that for now, minus 1 over 16, and then e squared to the 4 is e to the 8. So that's what you get when you sub in e squared. Now I'll sub in 1. Well, ln of 1 is 0, so I can just ignore that bit anyway. And what I've got here is minus 1 over 16 times 1 to the 4. So I need this as something times e to the 8 plus something. So what have I got? Well, ln of e squared is just 2. 2 times a quarter is a half. So I've got half e to the 8 minus 1 over 16 e to the 8 minus minus, so plus 1 over 16. So a half minus 1 over 16 is 7 over 16 e to the 8 plus 1 over 16. So just to really spell it out, a and b are 7 over 16 and 1 over 16 respectively. Question 13. In an arithmetic series, the first term is a and the common difference is d. Show that Sn equals that. Okay, so we're just proving the sum of an arithmetic sequence formula. So here's how we do it. We say, look, what actually is the sum of an arithmetic sequence? Well, you take the first term, a, then you add the second term, which is a plus d. Then you add the third term, which is a plus 2d. And you do that all the way until you get to the nth term. Now, what is the nth term? The nth term is a plus n minus 1 d. So the trick, if you like, not a trick but an insight, is that writing this backwards is a useful way of approaching it. You can pair things up in a nice way. So the final term was a plus n minus 1 d, etc., all the way back down to the second term, and then finally the first term. Now, why is this useful? It's useful because if you add these two expressions together, and they're the same thing, you get 2Sn here. And what do you get if you pair these up? Well, a plus n minus 1d is 2a plus n minus 1d. And if you keep working down here, you're going to find every single pair adds to the same thing. A plus d plus the penultimate term, which would have gone here, is also 2a plus n minus 1d. If you think about it, the number of d's is simply dropping down by 1 here and going up by 1 here each time. So they must be the same. So it's 2a plus n minus 1d all the way until the final 2a plus n minus 1d. How many do we have in total? Well, there were n terms in the whole sequence. So it's n times 2a plus n minus 1d. Finally, that was 2Sn, so Sn is just half of that. N over 2, 2a plus n minus 1d. Okay, that's part I done. Or part 2 is James saves money over a number of weeks to buy a printer that costs £64. He saves £10 in week 1, £9.20 in week 2, £8.40 in week 3, and so on. Show that the weekly amounts he saves forms an arithmetic sequence. So that the amount he saves forms an arithmetic sequence. Given that it takes him n weeks to save exactly £64, show that this is true. Well, what do we know about the way that he's saving? We know that the first term in the sequence is £10. So A is 10. And the difference, well, it's minus 0.8 because he's saving, it's 80p less each week. So that's the difference, is minus 0.8. We can then just sub that into our formula because we want this to take, sum to, rather, 64. So what is the n which gives Sn equals 64? Well, we want n over 2, the sum of the first n terms, to equal 64. Now, what is the sum of the first n terms? Well, it's n over 2 times 2a, which is 20, plus n minus 1 times d. d is minus 0.8. So it's that times n minus 1. And I just need to show that this will rearrange to this quadratic. Let's just check that it does. Multiplying by 2, I get n, and let's expand this as well. 20 minus 0.8n, and then plus 0.8 equals 128. Expanding and simplifying, I get minus 0.8n squared, and I get 20 plus 0.8, so plus 20.8n, and let's just subtract this as well, equals 0. Dividing through by negative 0.8, I get n squared. Now 20.8 divided by 0.8 is minus 26n. And then minus 128 divided by minus 0.8 is plus 160. So that is part A done. Part B is just solve that. So it's only 1 mark, so you can just sub this into your calculator. So when you do that, 1n squared minus 26n plus 160, you get 16 and 10 as your 2 solutions. So now, it just said solve the quadratic, which is we've done. Look at the question again. C is hence state the number of weeks James takes to save enough money to buy the printer, giving a brief reason. Well, it's obviously well, maybe not obviously, but it's the first one you reach. So it's not 16. We do Sn, the sum of his savings, does equal 64 after 10 weeks. So we can say 10 weeks, his savings first reach £64 after 10 weeks. Now they do, what's happening here basically is, since the amount he's saving goes down each week, in theory it would go negative and then he'd get back to 64 after 16 weeks, but clearly it's just the first time we get there that we're interested in. Question 14. In this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. Okay, given sine x minus 60 equals cos x minus 30, show that tan x equals that. So we're going to need to use the addition formula here. So 2 of sine x plus 60. Well, sine of x plus 60 is sine x cos 60 minus sine 60 cos x. Cos of x minus 30 is cos x cos 30 plus sine x sine 30. We can now simplify this and use a bunch of trig values we know. So cos 60 is a half, so I've got 2 times sine x times a half, that's just sine x. And then sine 60 is root 3 over 2, times that by the 2, and it's just root 3 cos x. What about over here? Cos 30 is root 3 over 2, so root 3 over 2 cos x. Plus, and sine 30 is a half, so that's half sine x. Now, we need to rearrange this to get tan x on its own. I can get tan x by dividing through everything by cos x. Here's why. Sine x divided by cos x is tan x. Divide this by cos x and it's minus root 3. Divide this by cos x and it's root 3 over 2. Divide this by cos x and it's tan x. Get all the tan x's on one side by subtracting half tan x. Get all of the root 3 over 2's, or all the numbers on the other side, add root 3 to both sides, and you get 3 root 3 over 2. Multiply both sides by 2, and it's tan x equals 3 root 3 as required. Hence or otherwise, solve this equation here. So, what's the connection between this? Well, the connection between this is that if 2 theta is x minus 60, then 2 theta plus 30 is x minus 30. Notice that what's in the bracket over here is precisely what's in the bracket here plus 30. So all we need to do is let 2 theta equal x minus 60. So when you go to solve this equation, 2 sine 2 theta equals cos 2 theta plus 30, that just transforms that into 2 sine x minus 60 equals cos x minus 30. We know that that implies that tan x equals 3 root 3. We can solve that, work out what x is, and therefore work out what theta is. We want to solve that for theta between 0 and 180. So I sometimes like to help myself out by saying, look, if theta needs to be between 0 and 180, well, that means that 2 theta needs to be between 0 and 360, which means that x minus 60 needs to be between 0 and 360, which means that x needs to be between 60 and 420. That's just, you're not going to get marks for this. This is just to help me see what range of x values I actually want. So if tan x is 3 root 3, I can do inverse tan of 3 root 3, and I get 79.1. Now, that is in my range, which is good. I'm going to just give myself a touch more accuracy. The next one I want, I can just add 180, because with tan we just add multiples of 180. So 259.11. If I add 180 again, it's outside of the range. So these are the two x values I want. Now, we just need to find out what theta is. So 2 theta is x minus 60. So I can just say, therefore, 2 theta is, well, these values minus 60. So 19.11 and 199.11. And therefore, my values of theta are these things divided by 2. And I want 1 decimal place. So that gets me 9.6. And 199.11 divided by 2 gets me 99.6. And we're done. Okay, question 15. A company makes toys for children. Figure 5 shows the design of a solid toy that looks like a piece of cheese. Oh, how wonderful. The toy is modelled so that face A, B, C is the sector of a circle with 0.8 radians as the angle inside there. It's got a radius of r. Faces A, B, C and D, E, F are congruent. So what is that? That's just the top face and the bottom face. So it is a prism, and edges AD, CF, BE are perpendicular. Okay, so it's just a normal, well-behaved prism. Edges AD, CF, and BE have a length of h, for height, I guess. Given that the volume of the toy is 240 centimeters cubed, show that the surface area is that. Okay, so we're going to need to basically find an expression for surface area in terms only of r. So the first thing I do is try to find an expression for the surface area in terms of anything that I have. So what do we have? Well, we have a top surface and a bottom surface which are the same. So I can start piecing this together, saying the full surface area is, well, you have 2 times the whatever the top piece is. Now, what is that? Well, that's a sector area, and the formula for a sector is half r squared theta. So that is half r squared times 0.8. So that accounts for this bit and the bottom bit. Now you've got these 2 rectangles at the side. Each one of those is HR. So I have 2 HR. And then finally I have this end piece, which is, well, you could imagine uncurving that, and it would just be a rectangle. You need the base, which is the arc length, times the height of h. The arc length is r theta, so that's 0.8 r, and the height is h. You've only got one of those. So that's r theta, so 0.8 r, times the height. So that is an expression for the surface area. Neatened up a little bit, we have s equals, well, the halves cancel here, and it's 0.8 r squared 2hr plus 2.8 plus 0.8 hr is 2.8 hr. So, is that what we want? No, because we don't want any h's. We only want r's. So how do we eliminate the h? Well, we use the fact that the volume is 240 centimetres cubed. What is the volume of this? Well, it's just the sector area of that top piece times the height of h. So what was the sector area? The sector area was half times r squared times theta. And when you multiply that by h, you get the volume, which we're told is 240 centimetres cubed. And this gives us a way to isolate h and therefore eliminate it. So neatened up, what do we get? Well, in total, I've got 0.4 r squared h equals 240. So what's h? Well, I'll do two things here. I'll do 240 divided by 0.4, and that gets me 600, and then divide by r squared, and I get that. And so I can just get rid of h in this expression by subbing in this. So what I have is the surface area S is 0.8 r squared plus 2.8 times h times r. So 0.8 r squared, 600 times 2.8 is 1,680, and then the r here cancels with one of the r's here, leaving 1,680 over r, and that was what we needed to show in the first place. Okay, using algebraic differentiation, find the value of r for which s has a stationary point. So I just need to differentiate here and set it equal to 0. So s dash, or ds by dr, if I differentiate this, I get 1.6r. Now what is this next one? This is 1,680r to the minus 1, so that's minus 1,680r to the minus 2, and I can set this equal to 0. 1.6r is equal to this, which I'm going to write now as 1,680 over r squared. That's useful because I can multiply through by r squared, giving me r cubed here. And I can divide both sides by 1.6. 1,680 divided by 1.6 is 1,050. So r is just the cube root of 1,050, which is 10 point. How many decimal places did they want? Well, find the value of r for which s has a stationary point. They didn't say, so I'll just give it 3 decimal places. Finally, prove by further differentiation that this value of r gives the minimum surface area. So how do you know when a stationary point is a minimum? Well, it's when the second derivative is positive at that point. So let's find the second derivative, s double dash. Differentiating this, I get 1.6. Differentiating this, well, 1,680 times 2 is 3,360, so it's plus 3,360 r to the minus 3. So let's just check. When r is 10.164, what is the second derivative? Well, I'll just sub it in. 1.6 plus 3,360 times 10.164 to the power of minus 3, and the answer is 4.8. That's positive, and therefore it is a minimum. And I've shown that this value of r gives a minimum surface area of the toy. All right, last question now. Figure 6 shows the sketch of a curve C with parametric equations x equals 8 sine squared t and y is 2 sine 2t plus 3 sine t. The region R, shown shaded in figure 6, is bounded by C, the x-axis, and the line with equation x equals 4. Show that the area of R is given by this. So this is some parametric integration. So the formula to use is that the integral is, well, normally it's y dx. For parametric equations, we use y dx by dt times dt. So we need to work out what dx by dt is. So dx by dt, we'll just differentiate this. Using the chain rule, we get it's sine t all squared. So that's 16 times sine t cos t. Okay, that's dx by dt, and so I can just sub that into this integral. So it's the integral of y, which is 2 sine 2t plus 3 sine t, multiplied by this, which is 16 sine t cos t dt. Right, that doesn't look very much like this at all. So how are we going to show that what we have here is equal to what we have here? Okay, well, I'm aiming really for this cos 4t. Now, notice that what you have here, sine t cos t, that looks like the sine double angle. So let me just use the double angle formula there. So 2 sine t plus 3, 2 sine 2t plus 3 sine t, well, that is going to be the same as 8 sine 2t. Expanding this now, I'm going to get 16 sine squared 2t plus 24 sine t sine 2t dt. So what have I got that I want? Well, not that much, but I can actually create some of what I want. Here's how. Recall that cos 2a is 1 minus 2 sine squared a. Well, that means that sine squared a must equal half minus half cos 2a. Replace a with 2t, and what we have is sine squared 2t is a half minus a half cos 4t. What I have here is 16 sine squared 2t. So it's this expression times 16. So that is 8 minus 8 cos 4t. Okay, looking up here, I've got the stuff I want there. That's great. Now, how do I get expressions in terms of sine squared t and not double angles here? Well, I can just use the sine double angle formula here. So what I have is 24 sine t, and then sine 2t is 2 sine t cos t. And that actually gets us what we need, because it's 8 minus 8 cos 4t plus 48 sine squared t cos t. Almost there, we just have to consider limits. So the original limits were 0 and x, 0 and 4. Now those were x limits. We need to convert those into t limits using this formula here. So we can say when x equals 0, and the formula was 8 sine squared t, 8 sine squared t equals 0. So we just get sine squared t equals 0, sine t equals 0, and t equals 0. You just take the first t value solution you find in this range. In fact, it's the only one in this range. Then when x equals 4, you've got 8 sine squared t equals 4. That means that sine squared t is a half, and sine t, well, okay, it's plus or minus root 2 over 2, but actually in the range we have, sine t is always positive, so it's root 2 over 2, and t is pi over 4. So that, in fact, is our upper limit, which was the a here. So a was that. I could just state that explicitly. A is pi over 4. Okay, hence, using algebraic integration, find the exact area of R. So let's just start afresh. What we're trying to integrate is the integral of, well, from 0 to pi over 4 of 8 minus 8 cos 4t plus 48 sine squared t cos t dt. So let's just dive into this. Integral of 8, well, that one's easy, it's 8t. Integral of cos 4t is a quarter sine 4t. Multiply it by that negative 8 and it's minus 2 sine 4t. Now for this one here, you could do this with a substitution, but I prefer just doing this as reverse chain rule, noticing that cos t is the derivative of sine t. So I can actually basically see the answer to this. It's going to be something times sine t cubed. Why is that? Well, imagine I differentiated this. The power would come down and drop by 1, leaving me with 3 sine squared t. And then I'd multiply by the derivative of sine t, which is cos t, which is what I want. So I've got my sine squared t cos t. Now what number here do I want such that when I multiply it by 3 gives me 48? We're at 16. So there's my answer. Now obviously you can write that as sine cubed t, but what does that mean? It means sine t all cubed. So now I can just sub in my limits. Subbing in pi over 4 gets me 8 times pi over 4, which is 2 pi. Pi over 4 times 4 is pi, and sine pi is 0, so you get minus 0 there. Now, sine of pi over 4 is root 2 over 2. Cube that, and times it by 16, and you get 4 root 2, so plus 4 root 2. Now subbing in 0, 8 times 0 is 0, sine of 0 is 0, sine of 0 is 0. And so this is our answer. Our answer is 2 pi plus 4 root 2. And that's it. That's the paper done. See you soon. Thanks so much for watching. If you found that useful, you might want to check out my website, mathematicswithwoody.com, where I've made a complete online course covering the full A-level math syllabus. For a fraction of the cost of a tutor, you can get over 70 hours of video content, hundreds of quizzes and worksheets, as well as support from me when you get stuck. The first 100 people to use the link in the description will also get 30% off. See you soon.